Okay, welcome. So what I'd like to do is kind of go over a quiz on polynomials that I recently gave to my students. So my name is Brian McLogan, and I basically make quite a few tutorials. And today I just want to kind of work through a quiz to kind of help some of you guys out that are working through a polynomials unit. And this was a quiz that was given in my pre-calculus class. And you can see here what we did is we kind of broke it down into some free response questions. I'm talking about zeros, multiplicity, looking at expanding binomials, and then also kind of finding the zeros. I'm going to fix this equation because that was a 2. Then writing the equation of a polynomial, and then what we'll do is we'll also get into some multiple choice questions that I covered as well. So then there's about 4 multiple choice questions that we worked on. So what I'm going to do is kind of cover through these, explain them kind of step by step to help you out. And then obviously if you have some questions in your own class, then after I'm done kind of working through the quiz, I will be happy to answer any of your questions. So I will take a quick little break after question number 4, just kind of check in the chat, see if there's any immediate steps on any of the work that I did. But otherwise, I'm just going to go ahead and get started with you guys. And then again, if you have any questions, feel free just to post them in the chat, and I will try to answer them as best I can once we get through. So here we go. Let's go and take a look. All right, so the first question says, graph the following, that's a little too close. Graph the following polynomial function to determine the zeros with multiplicity, y-intercept, and end behavior using mathematical notation. All right, so the first thing we want to do is, if we're going to find the zeros, I think the main important thing we want to understand is we want to set this equation, equal to 0. So I'm just going to say here is going to be so I'm going to replace that with 0. And then basically I can use a zero product property to set each and every one of these equal to 0. So now again, remember this coefficient -2, that's not affecting the 0. That's affecting like a vertical stretch as well as a reflection, but it's not going to be affecting the values of the zeros. So you can really attach the -2 to either one of these factors, but it's not going to really matter. And I'll even show you, -2 times x minus 1 squared equals 0, because here we have the product. And then we have, x plus 1 cubed equals 0. Well, the first step I'm going to need to do before I can even undo the squaring or, undo the subtraction on 1, I got to get rid of whatever number is being multiplied by. So you can see here how that -2 is not affecting the values of my zeros. Then we're left with x minus 1 squared equals 0. Now, to get rid of the square, I need to go ahead and take the square root. So I'm going to square root both sides. Now, I don't need to worry about the plus or minus in this case because I'm taking the square root of 0, and 0 is not positive or negative. So therefore, I'll be just left with x minus 1 equals 0. Add 1 to both sides. X is equal to 1. And then over here, to get rid of the cube root, or to get rid of the cubing, I'll need to take the cube root of both sides. And therefore, again, I'll have x plus 1 in this case is equal to 0. So therefore, x equals -1. Now, not only did I ask you to find the zeros, but I also asked you to identify the multiplicity. And remember, the multiplicity is the power of the linear factor. So, since both of these factors here are linear, they're both raised to let's put them up here. They're both raised to the first power. The multiplicity is going to be the power of those factors. So, since the 0 for this factor x minus 1 squared, the 0 is x equals 1, that's going to have a multiplicity equal to 2. And x equals -1 is going to have a multiplicity equal to 3. Okay, and you can write it like this. I also wrote it in set notation, which is perfectly fine, but that's exactly fine. We're just going to want to make sure we label this, and say, hey, here are the zeros. Okay, now let's go ahead and plot these on the graph. So we have a 0 at 1, and I'm just going to put a 1 like right here. And we have a 0, so that is going to be a x-intercept, a real x-intercept. Now I notice the multiplicity is 2. So what that means is the graph either bounces up or bounces down. So remember, when it has even multiplicity, it's going to be touching the graph and rebounding. Whereas at -1, we can see that this graph is going to be crossing. And it actually crosses at the curve of like a cubic function. So it's going to be a little S curve here. But for the simplicity of this, I am just going to say it's going to cross, and I'm not really going to show the curve, if it looks like this or, looks like that. So I'm not going to cover that because we're not trying to get like an exact graph. We're just trying to get a rough sketch. And now let's go ahead and find the y-intercept. So I'm going to label here the y-intercept. And if the x-intercepts are basically when y is equal to 0, then the y-intercept is basically when x is equal to 0. So I'm going to say y is equal to negative 2 times 0 minus 1 squared times 0 plus 1 cubed. Okay, just simplify that a little bit more. This is negative 2. 0 minus 1 is negative 1, but negative 1 squared is positive 1. 0 plus 1 is 1. 1 cubed is 1. And you can see here I have negative 2. So the y-intercept is equal to negative 2, which you could also write as a coordinate point 0, comma, negative 2. So let's go over here and let's graph that to negative 2. So let's go down. Negative 2, that's the y-intercept. Now the next thing is let's go ahead and identify the end behavior. Like, where is this graph going? Is it falling to the left? Is it falling to the right? You know, so on and so forth. Now, this might be enough information for you to sketch the graph, but we did talk about understanding end behavior using mathematical notation. So to understand end behavior, we basically need to identify the leading term. We don't need to identify the expansion of the whole polynomial, just the leading term. So if we were to expand this out a little bit more, so I'll say end behavior. And that's a really bad writing of end behavior, but that's okay. So end behavior, if I was going to expand this out, I would have y is equal to negative 2. And then if I was going to do x minus 1 squared, then my leading term of that expansion would be x squared. And I'm going to write dot, 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 because I don't care what the rest of it is. X plus 1 cubed would be give me a leading term of x cubed, dot, dot, dot. Now, if I were to multiply x squared times x cubed, that would give me x to the 5th, and then times the negative 2 would give me a leading term of negative 2 x to the 5th. And again, that's all I need to be able to determine the end behavior, because that's what we call the leading coefficient test only deals with the leading term. So you can see here this graph is negative. The leading coefficient is negative, and my degree is odd. So what that tells me is this graph is going to rise to the left and fall to the right. Okay, and that's just understanding the leading coefficient test, which obviously we covered in class. Now, before I write this mathematically, we can finish up the graph. We basically need to connect our two end behaviors going through these zeros. So by connecting them, I say I have to go through here, have to go through my y-intercept, have to connect here, and then have to connect over there. So you can see here that this graph is rising to the left and falling to the right. Now, I did say to go ahead and write this in mathematical notation. Yeah, my internet is going down. Sorry about that. So you can see my mathematical notation. I did say to write the end behavior in mathematical notation. So if I want to talk about this graph as it's going towards the left, I'm going to say, as x is approaching negative infinity. Actually, let me try one thing here real quick. See if this works. Hopefully it doesn't mess up my stream. I'll try this. See if this does anything for me. Come on. Oh, and then you guys are showing up in the chat. So you guys are here. Oh, so weird. All right, well, I'm just going to keep it on then. I'm not going to worry about it. I don't know why this. Oh, I guess my pop-up chat is not working. So let me pop up the new chat. Sorry about that. I just realized that my old chat was not working. So let's pop out a new chat. See if you guys show up there. There you guys are. All right, perfect. So sorry, I've been having a little internet, and it's still saying the stream is not giving me 100%, so I do apologize for that. But you guys, your chat is saved, so I can see what you guys. I can see you guys there. So I'll get to the chat here once I complete this, first section. Then we'll take a little break. So as x is going to negative infinity, that basically means as the graph is going to the left, you can see it's rising. So therefore, we'd say f of x is approaching infinity, and as x is approaching positive infinity, we can see that the graph is falling. So we'd say f of x is approaching negative infinity. Okay, so that is going to be my end behavior here in using mathematical notation. And I believe that is everything I wanted to do. Looks very good. All right, so the next one was expand the binomial completely. And basically what we do here is we kind of use the just kind of like the patterns with binomial expansion, as well as using Pascal's triangle. So the first thing I told my students to do was, rather than deal with the problem in its form of 2x minus y, I then told them to go ahead and rewrite this as 2x plus a negative y raised to the fifth. So therefore, what we could understand is this first term, remember, always starts at the power of your binomial expansion and then goes in descending order, whereas the second term starts at 0 and then goes in ascending order. Now, you don't need to show those terms to the 0 power, but I think it's sometimes helpful just to kind of see the pattern. So, just for those purposes, that's what I'll do. So we'll have 2x to the fifth negative y to the 0 plus 2x to the fourth times negative y to the first plus 2x cubed negative y squared plus 2x squared times negative y cubed plus, you can see it's the same thing over and over, negative y to the fourth, and then plus 2x to the 0, negative y to the fifth. Okay, now again, this is in the fifth expansion. So we, not only this, but you can see I left a little bit of room for my coefficients. And my coefficients are going to come from Pascal's triangle. And Pascal's triangle was a way for us to be able to understand what the scalar coefficients are going to be. So remember that the expansion of raised to the fifth power is going to have 6 terms. So I'm going to keep on creating Pascal's triangle. Remember, you can add 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3. And you can keep on building this up till you get to 6 terms, because that's how many terms I have here. If you count the terms, 1, 2, 3, 4, 5, 6. So I'm going to keep on going until I have 6 terms. Here I have 4, so I do 4, 6, 4, 1. And then my last round is 1, 4, 10, 10, 5, 1. So these are going to be scalar multiples that I'm going to multiply times each one of these expressions. So I can zoom out, I guess. So I'll multiply by 5. Multiply this by 10. That's hard to write in there. There we go. Then we'll do 10, 5. Wait a minute. Did I mess up? 1, 2, 3, 4, 5, 6. 1, 5, 10, 10. 1, 2, 3, 4, 5, 6. Where am I going wrong? 1, 2, 3, 4, 5, 6. So now you guys are getting a good access of me confusing myself, writing this in. 1, 5, 10, 10, 5, 1. I am just confusing myself. I have everything correct. Just going crazy. Okay, so now let's go ahead and simplify this. So we have 2x to the fifth. Well, 2 raised to the fifth power is going to be 32. And that's x to the fifth. And then y to the negative y to the first is just going to be 1. So I'm just going to leave that as that. Here I have 5 times 2 to the fourth here is going to be 16. Times 5 is going to be 80. But then again, you have negative y to the first. Well, negative y to the first is going to be negative y. So then this is actually going to be a negative 80 x to the fourth y. And then here I have 2 cubed, which is 8. 8 times 10 is going to be 80. And then negative y squared is just y squared. So that's going to be a positive 80 x cubed y squared. And then the next one, again, this is going to be negative because you have a negative term raised to an odd. So instead of doing plus, I'm going to write this as a negative. And this is going to be 2 squared, which is 4, times 10, which is 40. And then it's a negative, so it would be negative 40 x squared y cubed. The next one, I have 5 times 2x. Well, that's just going to be, 10x, and then negative y to the fourth. So therefore, that's going to be a positive y to the fourth. So that's going to be a 10x y to the fourth. And then last but not least, that's going to go to 0. So then you're left with a negative y to the fifth. And there you go. That's basically your expansion to the fifth power. That's a minus, what did I do here? That's a minus 80. Let's erase that. It's supposed to be a minus 80. That just looked weird. No, that's supposed to be a plus. That's right, because that's that's the first term, second term, that's the third term. Yeah, 8, that's positive. Okay, cool. All right, so now let's go and get to the multiplicity and zeros. So it says determine all the zeros and their multiplicity of the following polynomial. So we have the function here. First thing we're going to want to do is set this equal to 0. So 0 equals x to the 4th minus 5x squared plus 4. All right, and basically what we do is we want to be able to solve this. Now, we want to look into factoring, and what I kind of noticed is this is a trinomial, and this looks very, very similar to something that I have done before, which would be like a quadratic, 5x plus 4. And if I was going to solve the quadratic, right, you're basically looking at what two numbers multiply to give you 4, add to give me negative 5. And you could say, well, that one's not too bad. That's x minus 4 times x minus 1. And then you could use the zero product property and go ahead and solve it. Well, in this example, you can see that the numbers are the same. The only difference here is the powers are raised. So when I go ahead and write this, let's write it with the same numbers and then try to see how we can get to x to the 4th and x squared, x minus 1. So you can see the numbers are going to give you these same coefficients of negative 5 and as well as 4. But now what I need to do to get, instead of getting x times x to give me x squared, I need x times x to give me x to the 4th. So I'm just going to raise the powers. And what you'd notice is when you multiply this out, your middle term is still going to be an x squared because those middle terms will combine. So now what I can do is I can go ahead and use my the zero product property to set each of these equal to 0. So x squared minus 4 is equal to 0. And x squared minus 1 is equal to 0. So now, just to solve for x, I can add 4 to the other side. So x squared equals 4. X equals plus or minus 2. Add 1 to the other side, take the square root. So you can see x is equal to plus or minus 1. And again, now you might not understand, like, well, what is the multiplicity of all this? Well, let's look at this as a linear factorization. Because rather than using the zero product property, we could continually factor these out. So if I was to write the zero linear factorization here, basically just factoring x squared minus 4 down and x squared minus 1, I would get x minus 2 times x plus 2 times x minus 1 times x plus 1. And in this form, you can see that all these factors, all these linear factors, all have a power of 1. So therefore, my multiplicity of each 0 is just going to be equal to 1. And that gets a lot of students confused because they see the 2 here and they're like, oh, multiplicity of 2. But again, remember, it's the power of the linear factor. And there we go. That was it. That was it for factoring on that one. All right, so the next one is basically saying write the equation of the polynomial given the following zeros. So we have 0 with a multiplicity of 3. We have negative 2 and 2. And then we have 1/2 where the multiplicity is equal to 2. Okay, so remember a couple things when we're given the zeros, guys. Your zeros are basically your values of x that make the equation f of x equals 0 true. So we can say, x is equal to 0. We can say x is equal to negative 2. X is equal to 2. And x is equal to 1/2. I'm going to come back to the multiplicity statement. Right now, I basically want to be able to identify the factors. And so the easiest way to find the factors is to set each of these equations equal to 0. So basically, you could say like x minus 0 is equal to 0. You can add 2 here, so you can say x plus 2 is equal to 0. You can subtract a 2 here, x minus 2 is equal to 0. And this is the one where it usually gets students. Here, instead of just subtracting a 1/2 on both sides, what you're going to want to do is multiply by a 2 on both sides, and then subtract the 1. So when you do that, you get 2x minus 1 is equal to 0. And again, what this is doing, it's not like it's wrong to have the negative 1/2, but then you're going to have fractional coefficients. And we want to write our polynomial here with our integer coefficients. And the important thing is, if you guys remember the zero product property, if I use the zero product property, right, and I set each of these equal to 0, like let's look at here. If I say, x minus 4, I'd say x minus 4 equals 0 and x minus 1 is equal to 0. So therefore, x is equal to 4 and x is equal to 1. Well, basically all I'm doing in this problem, guys, is working this problem backwards. I'm given the zeros, I set them equal to 0, and you can see by setting them equal to 0, those are my factors. Those are what multiply to give me my function. So you can see here, these are my factors. So now all I need to do is write my factors as a product to give me my function. So let's write that over here. I'll write f of x is equal to, now again, remember, let's go back to the multiplicity game. This 0 has a multiplicity of 3, and this has a multiplicity of 2. So therefore, instead of writing x minus 0 cubed, I'm just going to write x cubed. X plus 2 times x minus 2. Now again, that's the difference of two squares, right? X plus 2 times x minus 2. I'm trying to do as much little work as possible, like writing it over there. So that's going to give you x squared minus 4. And then here I have 2x minus 1 squared. Well, again, that's a perfect square trinomial. That's going to produce a perfect square trinomial, which is 4x squared minus 4x plus 1. (4x plus 1). Okay, so now basically what I have here is I have a binomial times a trinomial, and that's kind of like basically what I need to multiply, and then I can just multiply everything by x cubed. So to do that, what I'm going to use is the box method, just because I don't really want to do distributive property because my work is already can possibly be like sloppy enough. So I'm going to use the box method, basically create a box to represent this product as an area. Over here I have two rows, and then over here I'm going to do 3 columns. And again, each column is going to represent a different term. So I'll have x squared minus 4, and then here I'll have 4x squared minus 4x plus 1. Okay, and now basically I'm finding the area of each rectangle, and then I'm just going to add all those up to get my final product. So this would be 4x to the 4th, and I like this better than distributive property for a organizational understanding, as well as kind of like understand why, you know, where multiplication, what that represents. 16x squared, negative 4 times negative 4x is going to be a 16x, and then negative 4 times 1 is going to be a negative 4. All right, so let's go ahead and write this over here. So now you can see here I have some common terms, right? Those are going to be common, and that's it. Just those two. So I have f of x. Now I haven't multiplied the x cubed yet, so let's leave that on the outside. But inside this, the area is 4x to the 4th. Come on, I hate when I do that. 4x to the 4th minus 4x cubed. And then negative 16x squared plus x squared is going to be a negative 15x squared. Then I have plus 16x and then minus 4. And now I can just distribute that x cubed to everything. And I finally get 4x to the 7th minus 4x to the 6th minus 15x to the 5th plus 16x to the 4th and then minus 4x cubed. Whew, let me double check. I got squared. Why is that cubed? Minus 4x. I should have multiplied. That should have been cubed. Yeah, that should have been cubed. Okay, so I got my answer. That's minus. I got a plus. Oh, that should be a plus. That's positive 16x, yeah. Positive 16x, and that's a positive. That's a negative, and that's positive. Okay, very good. All right, so what I'm going to do is I'm going to take a little break here, check in with you guys, and then what I'll do is I will go to the multiple choice. If you guys wanted to go ahead and work on the multiple choice questions, here's just a couple of them. I have like number 8 and 9 down there, so we'll kind of run through that in just a second. I'm just going to take a little break. So, hey Trinity, oh my God, I have 3 years till that grade. Well, 10th grade, hey, no cosine. Intermediate algebra, you guys are just checking in. That was, oh man, you guys are going in. Hey, David. David says, hey, Mr. McGlone, I'd like to thank you for all your videos. Help keep me going what you're doing. Thanks so much, man. I really appreciate the support. You know, a lot of what I want to do, guys, is you know, just make sure I can provide a lot of, you know, help for you guys. I mean, I have a ton of videos. I've taught everything from Algebra 1, algebra 1 to algebra 2 to pre-calculus to calculus, and working through all those courses is really like going through high school again. I mean, I've taught everything for multiple years, and I just know that a lot of times when you guys are working on math, it's not so much about the general understanding. It's usually like certain things that you're kind of missing. So the more videos that I can make that help you guys out, I think is the base. So hey Trinity, good to see you. See you're very smart. See, the thing is, that's one of those illusions that I'm very, very smart, or at least very, very good at math. Math was one of those subjects that I actually enjoyed, but I didn't really care so much about math class. I didn't really care for the subject, and I was okay with it, and I was okay at it, but I wasn't like a straight A student, or I wasn't the kid that, you give a problem and I just knew exactly what to do. I had to work at it. I had to practice. I had to do a lot of homework, and, there was a lot of times I struggled at it as well. So I ended up, obviously, going through and getting my degree in mathematics, and that's where my eyes really opened up as far as really enjoying the math. What am I thinking of? Math grade topic? I don't even know. I'm like losing my mind. I taught all day today, so it's all kind of crazy. So yes, math is great. The subject of mathematics. That's where I was like, wow, man, this is actually really cool. All these stuff we learned, and I'm like, now I can relate it to previous things that I, had learned as well, which I, thought was very, very cool. So, thanks, Elizabeth. I really appreciate you reaching out, and hope you guys can help. So, all right, so let's go and finish off the rest of the quiz, and then if you guys have any questions, I'll go ahead and look through this. I'll go into the end. Tariq, I'll get to your comment here in a second, because I see you for the biggest tip on learning math. I got you. I'll get back to it in a second. So next one is determine the linear factors. So basically on this one, guys, we're just looking at finding the factors. I see there are 4 terms, so I'm going to want to use the grouping term. So I'm going to want to group them, and then I want to factor out the GCF from each grouping set. So what you can see here is I can factor out an x squared. If I factor out an x squared, I'm left with an x minus 5. And then here I can factor out a negative 1. And that's going to leave me with a x minus 5. Okay, now I can factor out the x minus 5. And then that's going to be left with a x squared minus 1. Now what you can see here is the only answer here that has an x minus 5 is going to be C. And you can see the other 2 factors are x minus 1, x plus 1, because that's those terms continually factored down. And the next one says the second term of 2x minus y to the 4th. So that was very similar to what I did up here, isn't it? 2x minus y to the 4th. Yeah. So to the 4th, you can see the second term is going to have a coefficient of 4. All right. So we're going to have a coefficient of 4 from the Pascal's triangle. And then basically what I'm going to have here, if I'm going to do 2x to the 4th, if this was the expansion, my first term would be 2x to the 4th. And then I'd have a negative y to the 0. And then the second term would be 2x cubed times negative y to the 1st. And then from Pascal's triangle, I'm going to insert in that 4. So we think 2x cubed is going to be 2x times 2x times 2x, which is going to be 8x cubed. So I have 4 times 8x cubed. And then negative y to the 1st would just be a negative y. So we have 4 times 2, which is 32, times a negative. Do I see a negative 32? Yep. And there's my answer A. Next one, suppose the graph of the polynomial function y equals f of x has the following end behavior. And basically what they're asking is, which equation must be true? So this is saying as y is falling as x goes to the right. So let's look at this graph. So as x goes to the right, y is falling. And as x goes to the left, y is falling. So we don't know what the graph looks like, right? I mean, not like that. We don't know what the graph looks like, right? It can look any kind of crazy going through there. But all we know is the graph is falling to the left and falling to the right, all right? So basically what this question asked, which I added to my students, was, which one has to be true? Well, the degree of fx is odd. Well, the leading coefficient tells us if the degree is even, then it's going to fall left, fall right, or rise left, rise right. So therefore, A is not it. B, it is an even function. Now this one is a could. It could be true, right? Because if you had something that was like symmetrical about the y-axis, like a quadratic, that could be true. But it does. I made sure I clarified with my students that what is the one that has to be true. And again, you don't have to have something that has symmetry. Even, remember, determines your symmetry about the y-axis. Just because it falls left, falls right, doesn't mean it has to have symmetry. So that is not true. C has a minimum value. Obviously, guys, if the graph is continually down to the left from the left and right, there's not going to be a minimum value. D, the range is all real numbers. Well, that's not possible either. Again, if the end behavior is falling to left and right, there has to be an absolute maximum. That means the graph is going to be bounded above. So that one is right. So therefore, we can see that here the leading coefficient is a negative number. And that's true. Like you think about a quadratic, right? Quadratic rises to the left, rises to the right when A is positive, and it's going to fall when A is negative. Find the zeros of the function 7x cubed minus 28x squared minus 35. So therefore, if I'm going to find the zeros here, again, we're going to look into factoring. Always want to look when you're factoring to see what you can factor out. And you can see here that looks like each and every one of my terms is divisible by 7 as well as x. So I'm going to factor out a 7x, and that's going to leave me with a x squared minus 4x minus 5. Okay, now obviously 0 is going to be a solution. So that one doesn't work, and that one doesn't work. Now I basically just need to factor down x. I just need to continually factor x squared minus 4x minus 5. So by using the zero product property, or not zero product property, I can say what two numbers multiply to give me negative 5. So x minus 5. And then multiply to give me negative 4. Well, that's going to be x minus 5 and x plus 1. Now, of course, be careful here because we don't want to include negative 5 and 1 here for D. What we want to look at is the zeros, right? If I'd say find the zeros. So by setting each of these equal to 0, x minus 5 equals 0, x plus 1 equals 0. You can see here that x is going to equal positive 5 and x is going to equal negative 1. So B is going to be my answer in that case. All right, last but not least is the intermediate value theorem, and I added some different verbiage for my students for C and D, but we can still answer this question here based on the information that we have, at least for this. So it says use the intermediate value theorem to determine whether the polynomial has a real zero between the given integers, negative 1 and 0. Now, I don't know what the function f this function looks like. So basically what we want to do is, remember the intermediate value theorem basically is telling us if we have a value below the x-axis and we have a value above the x-axis and we're dealing with a function that is continuous, then between these values, let's call this a and let's call this b, there has to exist a value c where this graph has to cross, right? If you're going to go from here to here with a continuous graph, you're going to have to cross the x-axis somewhere, and that's what the intermediate value theorem is telling us. It's what we call an existence theorem. It's saying that there has to exist. So what we want to do basically is look at the values for negative 1 and 0 and make sure one is negative, one is positive, because it says, or this function, we know that's to the fourth power. We know it's a continuous function, right? It's a polynomial, so we know it's continuous. So we want to make sure that when we evaluate for negative 1 and 0, they give us some values, see if those are correct, or see if the function is continuous. So let's go ahead and check f of negative 1. So when I plug in f of negative 1, I get negative 4 times negative 1 to the fourth minus 2 times negative 1 squared plus 4. So negative 1 to the fourth is just going to be a positive 1. Positive 1 times negative 4 is a negative 4. Negative 1 squared is 1. 1 times negative 2 is negative 2. And then plus 4. And you can see f of negative 1 here is going to be negative 2. So I'm not getting negative 2 for these. So therefore, I'm going to knock these out. All right. So now let's go and look at, and actually let's go and check out f of 0. So f of 0 is basically going to be negative 4 times 0 to the fourth minus 2 times 0 squared plus 4. And you can see that f of 0 is giving me that 0, so that's 0 plus or minus 0, whatever, plus 0 plus 4, which equals 4. So what's important here is if we were to look at this, at f of negative 1, we're at negative 2. At f of 0, we're at 4. So between the interval negative 1 and 0, does this graph have to cross the x-axis? And the answer is yes. And that's why the answer is D. And I provided these solutions here to my students. But hopefully, guys, that was helpful for you. Again, some multiple choice questions as well as some, free response, just to kind of, get used to a little bit with polynomials. So I'll go ahead and, take a little break, see if you guys have, any questions that I can answer. I'll be happy to, kind of go over anything as long as it's something that I am comfortable with. But if you guys have any questions, feel free to add them in there. Just kind of checking in. Hey, Elizabeth, thanks so much. They refresh. I'm glad my trig videos help. Tyreek says, what's your biggest tip for learning math? It's kind of tough. I mean, I'd really say one of the biggest things, and I actually just emailed this out to people that are on my list is, my email list. I like to, kind of send a little tips and stuff like that. So this is actually this exact same question kind of came up that I read from, but, it's kind of like, some main things as far as like learning math. I mean, one is I think one of the tips is like understanding mindset a little bit math. Like, I really have a trouble when people are like, oh, you're either good at math or you don't good at math, or people say, oh, I'm a math, or when I tell people I'm a math teacher, like, oh, well, I was never good at math and blah, 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 blah. But the thing is, like, there's no such thing as math people and non-math people. And I think just understanding the mindset that, learning math is not the variable, but time can be the variable in learning math. So, a lot of times is don't be so hard on yourself. Give yourself time, right? And I think one of the reasons that I struggled with math early on is because I was into a rush. I was always comparing myself to other students. I'd see other students understanding this stuff and I didn't understand it. So I was always looking for like quick fixes. How can I just get this assignment done? Or how can I show, my answers as well? And I didn't understand what I was doing, but I just wanted to get it done because I wanted to be at the same level as everybody else, which is understandable, right? I think that's a little bit of human behavior in there. But the problem is, once you start doing that once and, a couple times, then you start not understanding what's going on. And, and obviously we know that math is building upon itself. So then finally came to a point where it's like, I, was in certain classes and I would have a very, very weak math foundation. So I had to go all the way back and really practice those essential skills. And, that's one thing I, let students do is, don't compare yourself just because you're sitting at a desk, with other students and people are getting it. Give yourself time, because I think for any of you that have worked really hard in a math class, you've noticed that, you might not get it day one. You might not get it during the lecture. You might not get it during the week. But if you keep on studying, you keep on practicing that, what you'll notice is like you'll get these little epiphanies like a month later, a couple weeks later. And that's a really good feeling. The problem is, a lot of our school system doesn't reward students to actually learning. It just rewards us for teaching it in a certain amount of time, giving you guys a grade, and then move on. So, one thing I'd say, just, give yourself the mindset, give yourself time. But what that also means is keep working at it, right? Don't just say, oh, I don't get this, I can't learn it. But, keep practicing, because I think the easiest way for you to overcome your struggles in math is to practice. Practice a lot. Practice problems that you can do, that you can check your answers, that you can do well, and just keep on doing it. And what you'll start seeing is you'll start recognizing patterns, and those patterns will help you be able to understand and visualize more complicated problems. So hopefully, Turk, that helps you out. Well, thank you, Patriots, Red Sox, Bruins fan. You are very welcome. What is your tips for passing geometry? It's been a couple years since that I worked on geometry. I think one of the important things for geometry, though, if I, remember, I'm not sure how your class is structured, but, I think it's really important to make sure that you, have a lot of those formulas and the theorems and stuff like that, because, if you're dealing with geometry with a lot of proofs, or, it's a lot of thought, it's a lot of applications of thought-based problems, not so much of like solve for X. I mean, those happen, right? But I know from I remember geometry, it's a lot of applying skill. So I'd really make sure that you have that fundamental toolkit. And when I taught geometry, that was one of the things. We had this huge toolkit of all these, theorems and all these postulates and everything that we needed to know. So making sure that you're really strong, have a really good foundation with that. Is what I think would be best suitable for you in the geometry class. All right, guys. Well, I'm kind of at my time here. It's been about 40 minutes for a live stream. Hopefully this helped you guys out. And again, I think I'm going to be back here. Let's look at, I'm going to have homework. Today is Monday, so I'll probably be going live, I think next Wednesday, or this Wednesday, I'm sorry. Either go live tomorrow or Wednesday. So I'll probably be looking around the same time. For those of you that are looking into that, we are going to be covering, I need to go live on irrational zeros, as well as, actually I need to go live twice. Crap, I need to go live Tuesday and Thursday. Yeah, Tuesday and Thursday I'm going to have to go live. So I'll go live Tuesday and Thursday. On Tuesday, I'm going to cover irrational zeros, and on Thursday, I will cover complex zeros of polynomials. So without it, Jonathan says I have a big test tomorrow, 6 functions as well as angular and linear velocity measurement and Mangos tips. Yeah, I mean, that's a lot. I mean, big trig test. I mean, I just make sure you know those, 6 trig functions. I mean, make sure you study them and practice, guys. I mean, there's nothing in particular. There's not enough specifics there. But I mean, I think if anything, one thing I can give you maybe a short little tip is, look at the problems in the back of the book. Look at the problems, that you have the answers to. Work on those extra problems. Practice it. Or, another tip for you guys that I wrote in my email yesterday or this morning was, find something that you have an answer to, cover up the answer, and then work out the problem. And then take the paper away, check your answer. If you did it right, move on to another problem. If you got it wrong, study why you got it wrong, take out a new sheet of paper, cover it up, and start doing the problem again. I mean, when I used to do this, I used to sometimes have to do a problem like 3 or 4 times before I finally got it. But that really helped me, minimize mistakes when it finally came time to test time. And it also really helped me kind of work through that process because, guys, I mean, your brain is just like any other muscle. It needs to go through that process. So the more times you can practice a lot of stuff for there, it's going to be beneficial for you guys. So anyways, I hope you guys for joining me on this live stream. And again, if you are looking for some more help this week, feel free to step in on Tuesday or on Thursday. Cheers, guys. Oh, I got to move that over. There we go. Now I'm all set.